Hello and welcome back to episode 5 of our series on orthopaedics. So today we're going to be talking about the external skeletal fixator. We're going to look at the principles of what it's made up of and then also the application of such a fixator onto a bone model. So firstly, starting off looking at the individual components, there's 3 which make it up. We've got the actual pin which engages with the bone, we've got the clamp which connects the pin to the connecting bar, which is our 3rd component, and these make up the single unit. So focusing a little bit more on the pins, there's different styles of pins. So when they first started out, we can look straight back to where we were discussing in one of our previous episodes, which is similar to that of the arthrodesis wire. So these have got the nice trocar tip, they're nice and sharp, they penetrate well into the bone, but they are smooth all the way down. Now the problem with that is that there is a risk of pull out of the bone if all these are placed on the same angle. So what we try and do is make sure we get angulation through the bone of these, and by doing that, we're going to find that rather than everything just going in a nice straight line, we put some angles in, and that's going to give us a much stronger fixator at multiple points over the bone. And ultimately, it's going to resist pull out at an early stage. Now from this, they moved on to doing what are called threaded pins. And initially, they brought out what was the negative threaded pin. This is where the thread has been cut into the bar itself. Now, if we put a pin through, we've got to be quite careful, because if that thread runs the full length of the bar as it goes through the bone, we do end up with a weak point just here on the outside of the bar. And over time with cyclical fatigue, there was a problem where they would snap. So one of the ways they developed and advanced on these pins were just to thread the transcortices penetration section of the pin. So basically it would engage into the bone, we'd have the full thickness at the site of where the side of the clamp, but then just on the transcortex we would get engagement, so that would give us some additional pull-out strength. But after this, things got modified even further. And at this stage they came on to what's called the positive profile pin. So whereas on this negative one we can see that this thread has been cut actually into the bar, in this positive profile pin the actual thread is sat on the surface, so the bar itself is narrower than the thread. This means that when these pins pass across, that thread engages and it's actually not reliant on the strength or cut into the strength of the pin, so it's not affecting that, which is great. Now we can either have what are called centrally threaded pins, as this is an example of, so this runs through and you can therefore apply clamps onto both sides of the bone, or we can have positive profile end threaded pins. For again, this is another example. So this goes in and this will be using what we call a unilateral configuration, where we've just got the clamps onto one side. Now looking at the different connecting bars, when we look at the small clamps and things, then we're going to sometimes only be able to use steel connecting bars, and it's just very similar to that of an intramedullary pin, just with the ends smoothed off. Now as we move on, and with advancements in technology, and also we're looking at weight, we've moved more onto the carbon fibre rods, and then we can use these for both the small and the large systems, and also they do the titanium now as well, which again are very light, very, very strong, and ultimately we want rigidity within these frames, so the stronger the better. Looking at the different clamps available, back in 1947 they originally brought out what was called the KE clamp, and this is a 3-piece clamp. We've got a little nut on the end, we've got a rod that passes through the middle, and then the hole in the connecting bar. And you know, these can work, they're still available, they work fairly well, and you tend to find that you put your connecting bar down the centre, you then construct your frame, you put your pins in, and then you can make your frame up. The difficulty with these is that if you want to add any additional clamps after you've made up the initial frame, you've got to dismantle the whole frame and then put it back on again. So it's just not as versatile. So as an adaptation to this, they brought out the SF clamp. I prefer this system, it's a much lighter weight system, and it comes in 6 parts, so it's just much more versatile. So with these, if we've constructed a frame, what we can do is unscrew our bottom clamp, we can twist that clamp open, we can shut it around our connecting bar and add on additional clamps at a later date, which is a real advantage sometimes when you've got these tricky fixators where you've got lots of different components all coming together and you've got everything lined up and you just think you need that extra pin. So that's very, very beneficial. So in addition to this, we need to make sure that we've got the other equipment. So we're going to need to make sure we've got a drill to put things in. Obviously this is battery powered, there's the new pneumatic styles and things that are out there as well. We need to make sure we've got the correct drill bits. And depending on the drill bit you use will depend somewhat on the thickness of the pin. We want to make sure we pre-drill the bones so that we don't get what's called thermal necrosis. If you imagine trying to drill a reasonable sized pin into a bone, there's going to be a lot of heat generated at that interface, and that can cause premature death of the cells. And ultimately it's going to really cause premature loosening of your pin. So by pre-drilling and then carefully and slowly drilling in your pin thereafter, you're going to reduce down the risk of thermal necrosis, you're going to get a better fit, and you're going to get a much stronger, longer lasting fixator on the leg as well. We also need to make sure we've got a selection of spanners available as well. And the different spanners will coincide with the different size clamps that we're using. Currently the clamps come in what's called a mini clamp, which is one of the little ones. They come as a small clamp, which is the medium sized, and then they've got the large clamp, which is the biggest that they do. In addition to these, you can get things like epoxy putty. So sometimes in very small animals where we haven't got the ability to fit clamps on, or we've got tight angles and things that we're working around, we can use epoxy putty instead of a clamp and mould that around the connecting bar and then build up our fixator in that way. These are really useful for things like distal fractures of digits, where we're going to put pins up through joints and connecting bars. We can mould them together and form spider web frames, and they're really, really strong. So that's our introduction. Our next stage is we're going to look on how to apply an external skeletal fixator. So now we're going to look at how to apply a simple external skeletal fixator. This is going to be what we call a uniplanar unilateral, meaning that this fixator is going to go down to one side of the bone. It's in one plane, so we're not putting different planes in, and it's just what's called your most straightforward. We're going to use an example of the femur, so this could be used for an anti-rotation fixator with just a simple pin at the top and a pin at the bottom. Now, if I was going to be doing this on an animal, I would always make sure that I would use a tissue guide of one sort or another. This is one example, there are others available, and this would allow me then to protect the tissues that go through. For the sake of the video though, to aid in seeing better, I'm just going to freehand instead so you get the idea. So firstly, we're going to drill our hole through the actual distal section of the bone. So we want to keep parallel to the bone, and we're going to go all the way through, and then we come out. So at this stage, for the sake of the bone model, we're going to move to the proximal aspect, and we're going to drill into the proximal section of the bone. Keeping parallel, we want to make sure we're in the centre of the bone to get maximum integrity and incorporation of that bone. And then we've come out there. So now we've got our two holes drilled, we can then swap over and then we can look at applying our pins. So for this example, we're going to use a positive profile end threaded pin. So with these, it's using a nice smooth action. If you were doing it in a real animal, you could also use saline irrigation to just keep everything cool, and then just work in slightly shorter bursts, just following your hole as it goes in, nice and smooth. What we don't want to be doing is generating too much heat. And now, normally when you're feeling this on a live animal, you're going to be able to feel that pin just penetrating. So we want to make sure that the trocar tip is fully engaged through the transcortex of the bone. We're now going to repeat this process for the proximal pin. So we've got our hole, we would use our tissue protector again, we're going to engage, and then we're going to go nice and smooth, nice and smooth. Keep on going slow. We could always depth gauge this beforehand, so we've got an idea as well to make sure we know exactly how far we're going. We've got to be very careful, particularly on something like the femur at the proximal aspect, because we are getting quite close to some potential big vessels there. So then once we're engaged, we've got our proximal and distal connecting bars applied, we can slide them off. And then at this stage, we want to slide on our clamps. So we've got our two clamps. It's important now to remember the orientation of your clamp. We want to make sure that the actual clamp section is the closest to the bone. So it's important we don't put it the opposite way round. We don't want it this way round where we've got the clamp further away from the bone. So that's one important factor. We're going to get a stronger fixator by doing this. So at first we slide our clamp on, and then we'll do the same with our second clamp, and then we can slide our connecting bar down through the clamps. Now, one of the benefits of using the carbon fibre clamps, and so connecting bars, is that it allows us to adjust where we need to be, and then we can actually cut these down. So these are really easy to cut. They're extremely strong, they're fantastic for cutting. So we then get our spanner, and we're going to just initially just tighten up, loosely hand tighten first, and just get where you want to seat your clamp. Make sure it's nice and straight on both sides. And then once we've got it engaged, you can then go to tighten the fixator up. So there we go. Here we've got a unilateral, uniplanar, external skeletal fixator. Fantastic for using as an anti-rotational vise if we're combining this with an internal medullary pin, for example, on the femur. If we were going to use it as a standalone, we could then, if we wanted to, add in additional clamps at different sites along the bar. We can use our clamps then as a guide for drilling them through into different angles. So then we can put additional clamps on, additional connecting bars and pins, and we can try and get 3 to 4 pins in each segment. We've got to make sure that though we may want to go close to our fracture site, we definitely don't want to penetrate through our fracture site with our pin, because this can affect our healing ability. Normally at this stage, we then trim these pins off on both sides, and then it's important to remember to make sure you tape those ends over before waking the animal up, just because they are quite sharp, and obviously we don't want our patient to damage themselves through licking or catching themselves on the legs and things, or damaging things like furniture and things whilst they're walking around or getting stuck. So now we're going to look at placing a pin in a cross fashion across the bottom aspect of, for example, a distal fascial fracture of the femur. So what we've got, we've reduced our fracture down. Imagine we've got a set of bone clamps over here. We've left them off just so we've got a better area to see the pin. We've got our pin. Then we're basically going to look at trying to angle our pin back from the condyle and up and just exiting. So we want to make sure that our cross occurs just around the level of the physis. So at the moment, we're going to put our pin on. We're then going to start our pin off and make sure we're angled. We're going to aim to our finger and feel where that pin needs to come out. So we can engage our pin, and then we're going to work our way up. So then we've exited just onto the far side. We can feel our pin. We don't need to go any further. So at this stage, we will remove the drill, slide it out carefully, and then look to bending the pin. Now, if we slide our pin bender all the way down and try and bend it, we won't always get it as flush as we want. So another way that we can do to try and get an improved bend on our pin is to first bend it upwards and then bend it in an S fashion. And we're going to bend it over and keep on bending it down. And then when it bends down, it's going to give us a nicer, tighter fit on the end of our pin where it goes down. We can then take that off, and we can use our pin cutters to then cut quite close to the bone. And then in this way, once we've bent that, we can then use our wire twisters to twist that pin so it sits nice and flush against the bone. Now there's two advantages to this. One, it's going to give us a flat end against our bone, so we've got a nice engagement on the end of the pin against the bone, which is good. The other main thing is we've not got a nice straight pin. We don't want a straight pin because it's amazing how much these pins can migrate, and they can travel quite far and distance-wise. So this is going to keep everything hooked into place. And also, should we ever need to go in and find that pin to remove it, it's going to be much easier to find.